Hello and welcome to the section 5.2 lesson today. Today we're going to be talking about finding slope and just everything that goes into finding slope, how to find it, where to find it, what to do with it, I guess even. The main concept of slope is that we're trying to see how steep or flat, really it's just how steep, a line is. And we'll say on a graph. That's mainly where we're going to focus is on a graph. Okay, so how steep or flat is a line? That's what that's what goes into finding slope. And so I stole this from just a textbook. It's a pretty good visual for the idea of slope. It doesn't take care of everything, but pretty good idea. So it says in words that the slope m of a non-vertical line is the ratio of its vertical change, the rise, to the horizontal change, or the run. And so we've always thought about, and you've probably heard it before, and I know that because I've taught enough middle school that I'm well versed in knowing that this shows up in that time. The slope is the rise over the run, the amount of vertical change over the amount of horizontal change. And sometimes in science you'll see them use triangles or the Greek letter delta to talk about the change in a value. So I'm talking about how much y changes over how much x changes. And the more, I'm going to say, abstract you can get with that, the better off you're going to be. The more literal you are, the more like, okay, well, it's y2 minus y1 over x2 minus x1. Yeah, I want you to know that. But at the same time, you're really just looking, how much does y vary between 2 points over how much does x vary between 2 points? And the more you think of it that way, I do think the more sense it ends up making. We're trying to see how steep this line is, and we need to have a common way to talk about it. We don't want to be almost like Neanderthals and look at, well, it's kind of flat. There's a little bit of a slope up, but it's kind of flat. We want to be able to talk in precision, and when we have coordinates, we can do that. So in other words, we take their coordinates, and we look at the rise, we look at how much it changes in y, divided by how much it changes in x. And there's a multitude of places where we're going to be finding slope. Okay? But it all comes back to how to do it given a graph. So how to find the slope of a line. Okay. So how do we do that? Well, number one, and this is given a graph, I want to find 2 points. You'll find I'm a big step-by-step person. Because even though I like to get to more abstract thinking about things, I'm really stuck with okay, but I need a process. If I don't know what to do, I need a process I can fall back on. So we want to find 2 points, and we want to find 2 true grid points. So I want to find 2 places where my line, my line here, crosses these little lines. Right? I want to find somewhere that it actually crosses this. I don't want to deal with something like this. Let me change colors and maybe make it a little bit thinner, just to show some variance. I don't want to treat this situation right here as if it crosses this intersection, because it doesn't, right? That has decimal values for points. I want hard set whole number values. So I'm looking for 2 places where that happens, and sometimes if I can, I may need to zoom in just to get a better look at things. I'm at my max zoom here, so we'll see what we can do. I think I would be, oh man, there aren't that many good ones. So I'm just looking from the left to the right. That's not a good intersection. That's not a good intersection. Neither is that. No. I could kind of work with that. I think that would work for me. It's not, it doesn't quite look perfect, but I think it's supposed to be. I'm a little bit hesitant of that. It looks like it's a little bit above there. I'm keeping looking. Yeah, no. And I think if anything, I'm okay with this one too. They both seem like they might be a little bit below the actual coordinate value, but I think that at the very least they match, and I can work with that. Okay, now we want to look at the rise over the run, the amount of vertical change over the amount of horizontal change. So we kind of have two options here. We can either think about coordinates, and I don't have really a good place to write that, but I'm gonna write my rules kind of in general. I'm gonna say that I'm gonna find the delta y, the change in y. Delta, the little triangle, okay, translation time. Triangle means delta. Delta means the amount of change. So I want to find the amount of change in y and the amount of change in x. And then step 3 will be to divide them. Or even just write it as change in y over change in x. Okay, kind of sciencey talk, kind of Greek language talk, or Greek alphabet talk, anyways. But yeah, we can handle it. So, looking for my vertical change first. How far up do I have to go until I meet the horizontal line that contains this next point? So I have to go up that far. And then that forces me to go over that far. Now, how far did we travel there? How much change did we have? This is my vertical change, is my rise, which is also my delta y, my change in y. Just rise is kind of a colloquial term, something that we could all kind of understand. Oh, rise, we think of up and down. And then run, we can convince you that that's horizontal change, okay, or delta x. So my rise, it goes up 1, 2, 3, 4, 5. It goes up 5. Since it goes up, it's positive. If it were to go down, it would be negative. My run, how far over does it go? 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, this one was kind of ugly, okay? But then I just write it. Once I did that, I would say that my slope, m, I don't know why we use m. For years, I've never been able to figure it out. Basically, we ran out of letters, and S looks too much like 5. I don't know. But m for slope is 5 over 9. Notice the really important thing is I always start on my left point and work towards my right point. I could do it the other way, but it's going to mess some things up. Okay, so I always start left and go right. If you want to, go ahead and pause the video for a second and do the next one. Okay, if you paused it, then we're good. If not, that's okay too. I'm going to start by finding 2 points. This one's a little bit easier. It seems like there's a lot of points here. I'm just going to go with these 2. You don't have to pick these 2. I think there are plenty of others that you could have chosen as well. I'm going to find my rise and my run. So again, I'm starting at my left point, and I notice that I'm not going up to get to my right point. I have to go down. So I'm going to go down until I'm on the same level, right? I'm riding an elevator, right? I have to get to a certain room, and that room is this other blue dot. So I'm riding an elevator until I get on the right floor, and then I can walk over to that room. Let's see what that change in y and change in x is. Change in y goes down 1, 2, 3, 4, 5, 6. Since it goes down, that's a negative. And it goes over 1, 2, 3, 4, 5, 6. It goes down 6 and over 6. The beauty of saying your slope that way, that it goes down 6 and over 6, the key word there is over, right? The key word there is over, because that means if I think of down as negative, down 6 over 6, the way I say it ends up being the way that I write it. Now, there's a little bit that should be done with reducing fractions. That's going to be just a -1. Okay, just a -1. I think right now we're halfway through. It's probably a good time for a little code word. The code word of the day. It doesn't always have to be something math related, because I want to make sure that you're actually paying attention. So the code word for today is going to be banana. Okay. Maybe write that right there so that when you go to do the Google form, you have that word written there and you can just look and say, oh yeah, the code word was banana. I'm grading spelling as well. Okay, let's look at some different types of slope. Let me go back to normal zoom level here. There's 4 classifications that we assign to slope. There's 4 different things that can happen based on the way the line is pointing. Not so much the steepness of the line, but there's something to be said about the direction a line is pointing. Everything kind of, we read from left to right, so I try to work everything from left to right. If a line goes up from left to right, it goes upwards, then that has a positive slope. If it goes downwards, it has a negative slope. If it goes straight across from left to right, then it has 0 slope. If there is no left to right, right, a vertical line, there is no left to right, we call it undefined. And here's how I kind of generalize that. I think of, I'm on a treadmill, because I hate treadmills. So I'm on a treadmill and I'm on the left. I'm always on the left. So here I am sitting here getting ready to go for a walk. And I think of how much effort or energy additionally I have to put. So it takes one thing just to do the walking, right? But then how much extra energy do I have to put in based on how that treadmill track is laying? If it's upwards from left to right, if it's an incline, right, I have to go up. I think of, I have to put in more work than if it was flat. If it was flat, I would just be walking, I'd be going on that treadmill, and all would be fine. But if it's pointing upwards, I have to put in more energy, more effort to make that same progress. If it's downwards, and I'm standing here on the left, and I'm going down this decline treadmill, gravity is going to help me out a little bit, right? I'm not fighting against gravity like in the upwards. Gravity is going to help me out a little bit, so that's a negative. I have to put in less effort to get the same distance result, right? I don't have to work as hard as if it was flat. Now, if it's flat, as far as the extra effort that I have to put in to go along that treadmill, that's just 0 extra effort. Okay, everything here is based on the extra effort. And then I get to this one. Now, if I'm on this treadmill, I'm thinking, what the heck am I doing? Right? I don't even know. He's thinking, what? What do I do? How am I supposed to walk on this treadmill? It's dead vertical. It looks like it's in the storage position. I can't walk on it. So it's undefined. Okay. Now let's look at when we're given, or when we're finding slope and given 2 points. Okay. I do have another sort of set of rules that I typically follow in this situation. The first thing I'm going to do is label x1, y1, and x2, y2. Okay, I assign one point to be x1, y1, the other point to be x2, y2. Step 2, I'm going to plug them in, plug values in, into the slope formula. I need to write that on the next line because it's a little bit longer than that. M equals y2 minus y1 over x2 minus x1. And then step 3 is to, I'm just going to say simplify. Do the math at that point. Okay? So these are the steps that I follow every single time I get one of these problems. Every time I'm faced with this problem, I do this every time. I don't think on step 1. Okay, I know that sounds weird to say, but on step 1, label x1, y1, x2, y2. If there's any doubt in my mind about what should be what, I don't think about it. I just go x1, y1, x2, y2. I label those. That's labeling them. I do that, and now I move to step 2. And typically I'll rewrite the generic form of the formula. y2 minus y1 over x2 minus x1. And then it's just a replace. Okay, I take every one of those values and I replace what I've assigned to it. I've assigned y2 to be 3, so I'm going to put a 3 here. I've assigned y1 to be 5, so 3 minus 5. Over x2 is 2, minus x1 is 4. 3 minus 5 is negative 2. 2 minus 4 is negative 2. And negative 2 divided by negative 2 is positive 1. So my slope is positive 1. Next one, do the same thing. x1, y1, x2, y2. Again, I'm not thinking there. I'm not trying to pick, oh, I like that one to be my x1 or I like that one to be my y2. I'm just writing their assignments in order, and almost every time I'm writing them in order. Okay. So then I go y2 minus y1 over x2 minus x1, and I plug them in and figure out what we have. y2 is 2 minus y1 is 5. x2 is 5 minus x1 is 1. And simplify. 2 minus 5 is negative 3. 5 minus 1 is positive 4. There we go, we're done. Negative 3 over 4. Do the same thing, x1, y1, x2, y2. Slope. Now I know it seems tedious to write this formula every time, but you'll find that it helps remembering the formula when you don't have it available to you. Let's see, y2 is 0, minus y1 is 3, x2 is negative 3, minus x1 is, 2. And simplify. 0 minus 3, negative 3. Negative 3 minus 2, negative 5. Negative 3 over negative 5 is the same thing as positive 3 over positive 5. That's the only simplification that can happen. Okay, then we can look at, if we need to, what does that mean the line looks like? Is it going upwards, downwards, flat, or vertical? Okay, It turns out that this one and this one are both going upwards from left to right, and this one's going downwards from left to right. This one has a negative value, so it's one of these that goes downwards. These two both go upwards because they're positive slopes. Okay. Go ahead and pause the video and give these problems a shot. Hopefully you had a chance to do that. I thought I could pause, but it looks like I can't. So we're just going to roll right into it. Okay, x1, y1, x2, y2, and rewrite the slope. Zero minus 6 over 8 minus 0, negative 6 over 8. That reduces to negative 3 over 4, just like the second one that we did. x1, y1, x2, y2. Slope equals y2 minus y1 over x2 minus x1. y2 is negative 4, y1 is 4, x2 is 4, x1 is 2. Figure out what that is. That's going to be negative 4 minus 4 is negative 8. 4 minus 2 is 2. Negative 8 over positive 2 is going to be negative 4. You could say negative 4 over 1 if you wanted to, but negative 4 works as well. Last one that we have here, x1, y1, x2, y2. Slope is y2 minus y1. Again, this does seem tedious, but I find that it really helps me because then I just get to replace each one of these with the value that I've assigned. 4 minus negative 1, you can put that in parentheses if you want to. That's kind of optional. x2 is negative 6 minus negative 6. Again, it's optional if you want to put those in parentheses or not. I don't know if it's always needed. But it's totally up to you. Biggest thing is subtracting a negative is like adding a positive. 4 minus negative 1 is like 4 plus 1, which is 5. Negative 6 minus a negative 6 is like plus a negative 6. I'm sorry, plus a positive 6. And that's a 0. And in math, we can't divide by 0. So what does that mean? Okay. If we try to plug it into a calculator, we're going to get a divide by 0 error. And what that means, our answer would be is undefined. If you were to graph those 2 points, you would find that it would result in a vertical line. So it's undefined. Okay. Now for what homework problems I expect that you do. There's a lot on here, as I've said before. I think that it wouldn't be too much to think about doing like 1 through 4. Yeah, maybe leave it at 1 through 4. 1 through 8 wouldn't be too much work. We get to a little bit more work when we start looking at the 2 points. So I would say maybe just 10 and 11. And then for application problems, these get a little bit trickier because there's some solving equations. I'm going to say that you should do number 1 to get a feel for that, and 4 and 5. Okay, so as far as what I would require you to do So required problems are numbers 1 through 4, 10 and 11, and then application 1, 4, and 5. Okay. That's your homework. That's what I expect you to do. Also get the mastery challenge done, and we will see you next time. Have a good day.